Ok, maintenant tout le monde ferme sa gueule.
So the first vulnerability we wanted to exploit on our application is the A1OS vulnerability, which is the SQL injection. So basically, in the login process, we were using a login function which is very unsafe, as it just compares the textual username and password that is submitted by the user in the text fields. That means that the attacker can input some text that can modify the MySQL request and thus change the meaning of the request and then allow access to the website, whereas those credentials are false. They still grant me access to the website.
So this is our safe application where the vulnerabilities have been mitigated. As you can see, if I enter SQL calls in the input fields, I cannot enter the pages I want to enter because the password is not corresponding with the hashed password we have in our database. So what we do is comparing the hashed password entered by the client with the hashed password in our database. So SQL injection vulnerability is mitigated in our safe application.
The second main vulnerability in the website is the broken identification and session management. In this example, the login system has been using the get method, which means that if I enter my credentials in the login system and I submit, in the URL or display my credentials, which can then be intercepted via the session cookies by an attacker.
In our safe application, the bad authentication vulnerability is mitigated because we have replaced the GET requests with POST requests. Thus our URL doesn't display the username and the password, so if I type what appeared in the previous URL, our system is safe. A major group of vulnerabilities is the cross-site scripting vulnerabilities. One that we have here is the stored cross-site vulnerability, and it is linked to the fact that the user in our application can post blog posts, and in that post he can write scripts, and the script we have right here is a pop-up, and it has been published on the 15th of January. And if I hover my mouse over the title, a pop-up should appear, and this is the primary way for the attacker to access our website. And the way to fix this in our safe application is to add the keywords of the script creating the pop-up into a list of disallowed attributes that cannot be added to the post, and this is how we fix this attack. And this attack can be very, very not pleasing actually, because it can appear on multiple tabs at the same time.
One major weakness in the security of our website is the insecure direct object references. In fact, we have given the possibility to the administrator to modify the privileges allowed to each user. So that means that if a regular user wants to access the admin section, he can edit the privileges of any user and make a normal user administrator, or make an administrator a normal user. In order to prevent this from happening, we just add a verification function at the beginning of the index of the admin section, so that now if I want to access the admin section, a pop-up arrives and tells me that the access is restricted because I do not have the correct credentials.
So as we were developing the website, we wanted a quick and easy way to get past security, so that we wouldn't have to insert our credentials each and every time we opened a new session. This is why we created the page quicklogin.php. By going directly to this link, we can log into the website without having to insert username and password. For obvious reasons, this isn't safe at all, because if a hacker managed to get his hands over this file, he could enter the website and attack it in any way he wants. The way we fixed it was to take away the quick login page, so that now if we try to access it directly through a URL, it leads us to an unfound error message.
Another vulnerability that appears in our website is the A6 OWASP sensitive data exposure vulnerability, and we made this vulnerability appear in our website by designing a script that essentially makes backups of the whole file base and converts it into a text file and places it at the root of our web application. And this is a transit of sensitive information and gives the opportunity for attacks of the type of man-in-the-middle and other attacks involving direct access to the text files you can see in the index of our application. And in order to fix this, one of the main solutions is to encrypt all the transits of data and also other measures such as disabling autofill in passwords and protecting the passwords using different tools. So this is how we mitigated this A6 risk in our application encryption.
So the next hack we're going to talk about regards access control. This is basically when a user account can access admin pages just by modifying the URL bar. So as you can see, I'm in the index.php for users, but if I type in admin/index.php, I will get access to the admin page. Therefore, I can view users and check out other restricted functionalities. The way we fix this hack is we enabled restrictions to detect whether a user is a normal user or an admin. So now, if we try to access the admin section, this will redirect us to an empty page, and the user will have to log out and log back in again.
Another vulnerability of the application is cross-site request forgery. So what we have done is that we have submitted a new blog, and inside the blog we have introduced a malicious script that every time we want to display the blog shows a pop-up on screen saying something went wrong, and when we press OK, it automatically logs the user out. So we have forced the user to submit a request to the system without knowing it. In order to mitigate that vulnerability, we decided to add a script in the part of the code that is in charge of adding the submission of the file to the database, and that plugin disables the HTML parsing of the script. So that means that now we have adding the same script to the same blog, but now the plugin has disabled the pop-up, and the script is only displayed as plain text on the website.
One of the main vulnerabilities in our application is one that involves using a component for which we know the vulnerabilities. And our third-party application that we use within our website is a PHP mailer. PHP mailer enables users to write emails and they are processed through their shell. And the problem with this third-party component is that the user could write scripts in their emails and generate malicious behavior that way. In our safe application, we mitigated this risk by not letting the user actually compose their own emails, but rather send an automatic email that has been pre-written and that will be sent to the administrator with the requests the user needs. So, for example, here we have the send an automatic email button, and in that way we still assist the user in his usage of our application, but without letting him the opportunity to actually write malicious scripts. So that is how we solve that risk in our safe application.
The last vulnerability on our website is unvalidated redirects and forwards. For instance, this option redirects me to a file called redirect.php that takes a URL as a parameter. However, the attacker can modify the URL here to make it point to another website than the desired one. In order to mitigate this vulnerability, we decided not to use those type of redirects and forwards.